everyone, Anthony Silva here, and welcome back to my LeetCode demonstration videos. So I'm going to be doing another problem for the arrays and hashing problem set today. So we're going to take a look here. So it's the valid anagram problem that I'm going to be doing today. So I guess to start off, we can read the question real quickly. Given two strings S and T. Return true if T is the anagram of S and false otherwise. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. Alright? And example 1, an anagram and Anagram. Alright, so looks like these two are anagrams, so this function return true. How do we know? Well, looks like S and T both have two A's. There's an N in both. There's a G in both. R in both. Oh, there's three in this one. Wait, isn't this one? The three A's in this one? Yes, there is. And then there's an M in both. And there are no extras. So these two have since these two have the same letters and same letter frequencies, they're anagrams. So this function will return true in this case. And example 2, we have rat and car. Looks like both words share an R, both words share an A. However, the difference is that S has a T, but T has a C. So it would have to output false in this case because they are not. Okay. And then going to constraints here. 1 is less than or equal to S.length, T.length. So strings can be at least one character. They will never be empty strings. Strings can be quite large. And S and T consists of lowercase English letters. Okay, so we don't have to worry too much about casing here, guys. I think this is probably going to be a pretty simple solution here. We're going to do this in Python, actually, because that's what I'm going to be doing all my videos on is Python. But anyways, I'm just going to write out a multi-line comment here. From the first video, we did our planning situation thing right up at the top, and then we have our code down here. All right, so there are actually a couple solutions that we might want to try to implement. The first solution that I can think of that should only work with 3 lines of code, and involves sorting the problem, sorting each string. So, yes, the strings are immutable. However, it is possible to actually sort these strings out. It'll just return a different string. All right. So I guess we can sort S, and then sort T, and then the third line. Well, if these two are anagrams, they would have the same letters, right? And what you might notice is that when you sort S and T, all the letters in these strings right here are going to be sorted in alphabetical order all the way. They must be in the same order for them to be anagrams. So return whether or not S equals T. So that means they're the same string. Okay? Pretty simple, easy to implement. However, it is very important to notice the time complexity here. It's an n log n solution here, because we would have to use the built-in sort function for strings and arrays. So it would end up having to use the divide and conquer approach, and we would have to run the sort function for both strings S and T, just to make sure that these two are equal once both their strings are sorted. So It's not exactly the best solution here, but we could do a little bit better. Other solution that I came up with is to use a hash map instead. So we could define a hash map and set default values, key values to 0. So anytime we declare a key, it's going to end up defaulting to 0 when we first declare it, or at least that's what we planned. So we're probably just going to be fine using just one hash map, and then we loop through S, and then we would add 1 to the value of each key, a key found. So the way it would work is that, for example, this problem right here, we would loop through S first. So we would add 1 for A, so 1 for N, 1 for A again, so the value for A would be 2. Do 1 for G, 1 for R, add 1 more for A, so the value would be 3, and then add 1 for N. All right? Now, now we want to loop through T. So the way that I'm setting this up is that we add 1 of every letter of S, then we subtract 1 of every letter from T. We want to make sure, in order to verify that these two strings have the same letters and the same frequencies for each letter, we want to make sure that the values are going to be 0. So if we added each letter into the hash map for S, it only makes sense to subtract 1 for each letter in T. All right? And then lastly, we want to check to make sure that every single key's value is set to 0. So we would have to loop through the map. So we would have to loop through every key in the map, and if a key's value is not 0, return false. Because we would have found a difference in the letters for both strings S and T, so which would verify that they are not anagrams. And then if we manage to make it through that last loop without finding any differences, we would confirm that both strings have the same letters. So we would return true. All right? Now, I know this is a lot of for loops. All right? However, we really only got to worry about the fact that these would loop through n characters for each string here. So it would just have to be an O of n time complexity here. Again, we do want to mention space complexity here. We want to mention the fact that we are adding an extra hash map here. So we are going to be considering an O of n time space complexity here. All right. Now, give me just 1 second here. I'm trying to figure out. I'm trying to recall. Recall how to iterate through a default, through a hash map in Python. Because that's the one thing that I cannot figure out entirely. Okay, so all right, so it's just like so just like dictionaries here, but we're not exactly going to be using dictionaries. We're actually going to be using the collections module and import the default dict structure. All right, so what this does is we can initialize a special kind of dictionary that would set an initial value. Say, if we were to initialize a hash map here, say we call this char frequency, we would initialize this as default dict int. So that means we are going to establish our hash map here as a set of as that has values as integers. All right. And another thing you want to keep in mind is that whenever we declare a key in this hash map here, it will initialize our values to 0 once first declared. So we do not have to worry about checking to make sure that key exists in the dictionary. So we could start off by saying for character in S, we would start off by doing char frequency character. We're gonna add 1 to the current value. Then we can loop through the characters in T. And then we would just have to return -1 here. 1 here for the key's value here every time we come across a character in T. And then lastly, we just got to loop through the map. So we got to write one more for loop here. So key value in character frequency items. So we would have to loop through every key value pair in this hash map here, and check to make sure that the value is equal to 0 every single time. And if not, we will have found a difference in the two strings, so we will have to return false in this case. So if value does not equal 0, we return false. And then if we make it through that last for loop, we return true. All right. Okay, so one more thing that I want to add before I try to test this out. We do not exactly have a specification that S and T are going to be the same length. So we could try to make sure we could try to avoid unnecessary steps by proceeding with this function only if the lengths of S and T are equal. because if they're not, they can't have the. It is impossible for them to have the same letters and the same frequencies of letters because they're not the same length. So it would be obvious to have to return false. I mean, now, no, this is pretty subtle, but it is important as a step we want to add here, just to make sure we don't run into any unnecessary steps here. Okay. Now let's try to run this. Make sure this works just fine. Okay. Couple test cases passed. Let's try to submit this and see if this comes out just fine. Yes. All right. So we did it, guys. This is our Python solution for our valid anagram solution. All right. Unicode characters. What are those? Ah, okay. So that's a different problem that I'm going to leave out for now because this one is not going to. It does not make too much sense to me, but I highly encourage that you try to answer this question here because it is important to consider any other variations of these problems because you never know. This this problem might come up in an interview, but not exactly in the same format as this. It might turn out to be this. It might have uh, lowercase letters instead of uppercase letters. Like if it had lowercase and uppercase letters, I would have to make sure that I would try to make sure that the letters I'm checking are in lowercase. And if there are like spaces involved, we didn't want to include spaces to check if they're anagrams or not. We could add in some functionality to make sure we don't count spaces when checking for anagrams. Just a lot of stuff to think about as you try to come up with uh, some similar problems that are similar to this in order to prepare well for interviews. All right, but yeah, this is going to be our solution to the problem today. Hope this made sense. I will post a C++ solution in the comments for those who want to see a solution in C++. And then lastly, if you have any other questions or follow-ups or questions I should do or what I did not make clear on, please leave a note in the comment section below this video. And don't forget to hit the subscribe button for more videos because I will be back again for the next problem in the set. Okay? All right. So thanks for watching, guys. So long.